All right, chapter 3, question 160. A mixture of carbon and sulfur has a mass of 9.0 grams, and complete combustion with excess O2 gives 23.3 grams of a mixture of carbon dioxide and sulfur dioxide. Find the mass of sulfur in the original mixture. Okay, so two different mass equations in this case. We had some mass of carbon and sulfur. So let's see, mass of carbon plus mass of sulfur equals 9.0 grams. Right? And we also had a similar expression for carbon dioxide and sulfur dioxide. So the mass of carbon dioxide and the mass of sulfur dioxide equals 23.3 grams. Okay. Now the question mentioned something important: complete combustion. So that means that the moles of C here and the moles of CO2 are 1-to-1, and the moles of S and the moles of SO2 are 1-to-1. Right? There's no reagents that are still remaining after besides the excess oxygen. So we need to. So what we're going to do is we're going to find the moles of oxygen first. And we're gonna write an expression in molar terms. I think this one right here. Okay, so moles of oxygen, we can find the mass of oxygen because these O2s are the only difference between this mass and this mass, because we know that all of this was consumed in the combustion reaction. So we can write the mass of O2 equal to this mass of sulfur and the mass of carbon. Actually, that should be the other way around. Sorry, excuse me. Yeah, let's not make some negative figures to have to deal with. All right, so both the products minus the mass of the reactants. All right. This is 23.3 minus 9 for a grand total of 14.3 grams. Okay, that's great. And let's get the moles from that. So moles of O2 is the mass over the formula weight. That is 14.3 grams divided by, and this is O2, so we're doing 16 times 2 for 32 grams per mole. Sorry, excuse me. And that is equal to 0.4469 moles. Okay, so now another stoichiometric point to notice is that the moles of O2 in these compounds here is the same as the moles of the other nonmetals that they're with. Right, so this is 1-to-1 carbon to O2. This is 1-to-1 sulfur to O2, which means that we can just transplant this total directly into this expression here, and we can write it in molar terms. Oops. So let's mole total of the reactants equals 0.4469. All right. So then once we have that, we're going to have a substitutable reaction to put into the formula weight ones that you've seen me write a couple times now. Okay, so if X is, let's say X is the moles of carbon. All right, so X equals the moles of carbon, and Y is going to equal the moles of sulfur. And therefore, if I have X plus Y, I get 0.4469. Right, again, because of the stoichiometry of the O2 to the S and the O2 to the C in here, right? 1-to-1 means we can do exactly this. And we're looking for sulfur. Yeah, so let's solve it for X, so that we're left in sulfur terms, and then we'll solve the next thing for y, right? So, well, let's just write that over here. X equals 0.4469 minus y. Minus y. There we go. Get rid of that there. And let's do the real kahuna. Okay, so X moles of carbon. Carbon, we're writing the formula weight here. Grams per mole plus Y moles of sulfur. And this is 32.07 grams per mole. Right, and this is equal to the 9 grams that we had for the reactants. Okay, moles cancel. Got grams in common in each of the terms, so we're going to divide those out. Right, we are left with, that's 12.01x plus 32.07y equals 9.0. Okay, so let's substitute for x here. So 12.01 times 0.4469 minus y plus 32.07 y equals 9. All right, expand this out. 5.367 minus 12.01y plus 32.07y equals 9. All right, home stretch. Like terms. Equals 3.633. Solve that for y. Gives us 0.181. All right. So I'm going to write that over here now. Y equals 0.181. Okay. With a space there, we're now going to solve for the mass. Mass of sulfur with y. Right? Easy enough. So mass of sulfur equals the moles of sulfur times the formula weight. All right, moles we just solved for, that was y, 0.181 moles. Formula weight of sulfur is 32.07 grams per mole. You guys are going to have these memorized by the end of this. Moles cancel. We get a result in mass 5.80 grams of sulfur. And there you have it.